high security and interoperable OAuth 2. What's the latest? What's going on in the standard space, and how do all of these specs like the security BCP and FAPI2 belong together? We're Joseph Heenan, CTO of Authlete, and I work as a security and standardization expert for Authlete. And in this talk, we'll tell you about why OAuth 2 alone is insufficient if you have high security application, and if you want that to be interoperable. It's not enough to say just use OAuth 2. Then we will have a longer part about FAPI, and that includes FAPI2, which we will then do a deep dive on. And last but not least, tell you a bit about the current status and the adoption of FAPI and FAPI2. So, you all have heard about OAuth 2.0 or 2.1, and you might have applications for it. There are certain applications that do require really high levels of security, like e-health, e-signing, insurance, banking, finance stuff, consumer data, digital identity ecosystems, e-government, all of those applications where you have data that really needs to be protected, where it's more than, say, a social media account. And you might be wondering, what should I use to secure that? Should I use OAuth 2 or 2.1, whatever? So the thing is, in these ecosystems, you usually need more than what OAuth 2 delivers out of the box. So what are those requirements? First of all, obviously, you need the highest levels of security that you can get. That means that you would probably be looking at the OAuth security best current practice, which is not an IETF draft any longer, which now is RC 9700. So you need highest level of security. So you would look at the best current practice for OAuth 2 security. And that is the RC 9700 or BCP 240. And in that document, it's a long document, you will find lots of our learnings from practice and from research, how to protect against access token misuse, mix-up attacks, and more, and avoid all those insecure options that are in the original OAuth RFC. And the general idea of that draft is to, of the document is, I need to stop saying draft, of that document is to essentially provide 2 layers of defense. So even if your access token is stolen, that you still have a protection against misuse, or your authorization code is stolen, you still have protection against misuse. And yeah, so that's the general approach there, which is great, but it's also a 46-page document. There, I counted at some point 68 musts and must not, and more than 50 other requirements and recommendations in there. So it's a lot, and it's not super easy to process. Of course, we tried to write it in a way that makes it easy to read and implement, but yeah, there are limits to that. So you could take a look at OAuth 2.1, because essentially OAuth 2.1 is like OAuth 2.0 with the security BCP applied and then some extras. But that would still leave you with a general purpose profile. So OAuth 2.1 does not enforce the high security options in all the places. So it does remove some of the insecure or less secure options, but doesn't really enforce only the high security options. And it's not an interoperability profile. So just like the original OAuth, you might end up with 2 implementations of OAuth 2.1 that cannot talk to each other, because there are different options to doing various things. So yeah, so you need OAuth 2.1, the security BCP, or OAuth 2.0 and the security BCP, and you might want to have additional security hardening as well. And talking about interoperability, OAuth 2.x has a lot of optionality. So there are grant types, authentication methods, security mechanisms, cryptographic algorithms, and other choices that you need to make. And that is So that leads to non-interoperability if you make different choices on different ends of your ecosystem. And then in a high security ecosystem, you oftentimes also find other problems that you need to solve. For example, how to ask for a complex consent. Complex consent in that case, for example, means how do you ask a user to authorize a transaction of 27 euros to a bus company because we need to participate in a Northern Lights tour. That's a complex consent. How do you express that? Certainly not with a simple scope value. That's something you need to come up with, that you need to solve. How do you manage existing grants? So you have granted an authorization to a client, but you want to revoke it. How do you achieve non-repudiation and other things? So there are various things that you usually need to solve in this ecosystem in an interoperable way. So that's a problem. And then we have today already heard about a couple of considerations regarding conformance testing. How do you ensure that everybody follows the rules in your ecosystem? It's not easy. So you need to have tests. You need to check that people are actually doing what's in the spec. OpenID Connect has a great conformance testing program. It's great, but it's not for all. It's for OpenID Connect. So what if you just need the authorization part? You just need OAuth. Where do you get the conformance tests from? And all of these things can be solved. Authorization can be solved with OAuth 2. The conformance tests and authentication can be solved with OpenID Connect. If you want more security, you can use OAuth 2.1. That is, of course, not OpenID Connect. You can still stack OpenID Connect on top of it, but yeah, it's not that. And interoperability. And FAPI is the one thing that delivers all of that. So that is how these specs relate to each other. And what is FAPI, you might ask? Well, FAPI used to stand for Financial API. It turns out it's not really an API. It's more like a financial API security profile, because it's not talking about the API. It's just saying how to secure it. And then people noticed, yeah, it's not really about financial things. So we don't tell you how to secure your bank resource server. We tell you how to secure your resource server. So you can use it in all kinds of applications that have requirements as high as in the financial industry. So you could also call it financial grade API security profile. So it was renamed so that people don't think that they cannot use it for their insurance project. The problem is that, names and how they are read and interpreted. Financial grade API was still very much seen as something for the banking industry. So it was renamed again in FAPI security profile. So it's just that. There's no explanation for FAPI. And if you have ever heard an explanation, please forget it. It's just FAPI.
And my colleagues at IDF liked that slide so much they actually made me a shirt with it on the back.
We got a t-shirt for that. This is really just a t-shirt exchange event. It's not about anything else. Yes, so that is FAPI. It's a security, interoperability, and feature profile for OAuth 2. And you can use it for all high security APIs. E-signing, e-government, all the other stuff that I mentioned. And FAPI 2 is an evolution of FAPI 1 based on industry experience. So we took FAPI 1, we improved security, we improved the interoperability, and simplified development. So probably you might want to use FAPI 2 these days. What does FAPI 2 consist of? Couple of things. The first thing here on the bottom is the attacker model. The attacker model defines what we want to protect against. It's not like a threat model, so we don't list all the single attacks that might occur, but it's more describing the kind of attackers that we want to defend against. For example, an attacker that has access to certain messages because we assume that these messages could leak somewhere. Or we assume that there's a network attacker. So the whole network could be under control of an adversary. That adversary could try to mix messages or whatever. So mostly HTTPS protects against that, but also some other considerations. So that's the attacker model. That tells you what we want to, like what level of security we want to achieve. And then there's the most important document. So if you only read one document, please read that. The security profile. That tells you the do's and don'ts for secure, interoperable OAuth and OpenID Connect implementation. It's both. So you can use it just for OAuth or OAuth and OpenID Connect as you wish. That defends against all the threats that we defined in the attacker model. So if you find something in the attacker model where you think this is something we should defend against, then the security profile should protect you from that kind of attacker. If you don't find it in the attacker model, you're on your own. So it's also, the attacker model is also about like delineating what we want to do and what we don't do. Yeah, but the security profile is where you want to start reading. And then there are optional add-ons like message signing when you need non-repudiation. So sometimes you have exchanges where you want to ensure that people can store the messages they received in order to enable auditing later on. It's essentially signing messages. That's why it's called message signing. Then there's CBAR, client-initiated back-channel authentication. That's for certain kinds of decoupled interactions. For example, when you want to authenticate during a call center interaction. And then there's brand management, which is doing the thing that I mentioned before, where you can say, okay, I have already consented to something, now I want to revoke that, or I want to expand existing grants and stuff like that. Yeah, so these are the building blocks, and Joseph will now take you on a deep dive through the various things that we have in the security profile, especially.
Yes. Yes, so if you thought the last bit was geeky, then you've not seen nothing yet. So yeah, so FAPI 2, as Daniel said, is all about security hardening. So just going to talk about some of the choices we made and why they mean we have better security, basically. So first one, let's talk about sender-constrained access tokens. So probably most of you remember this news story. A couple of the CI vendors got breached, and the attackers were able to steal the OAuth access tokens that gave access to, I think it was thousands of companies' private Git repositories. So they basically lost the privacy of their code because the access tokens were stolen, and in base OAuth, a stolen access token can just be reused by the attacker. There's really nothing to prevent that. And this was also one of the issues that was called out. If you remember, there was a big Microsoft breach where attackers got access to government email accounts and things, I think. And there was a big review by one of the US cybersecurity bodies, and one of the recommendations that came out of that as well was that you need to stop using bearer tokens. These things aren't good. We've got better technologies these days. So FAPI 2 says you do have to use sender-constrained access tokens. So what that means is that when the client is requesting an access token, the first thing it does is it creates a key pair, so a public-private key, RSA, whatever. And then when it makes the token request, it does a signature to prove that it has possession of that key. And then when it gets the token response, that access token is returned bound to that public key. So what that means is that when you actually do the resource request, you need to present not just the access token, but something signed over with that key that's unique to that request. And the resource server checks the signature and it gives you access. So if the access token leaks, the attacker can make the resource request, but you really hope that the key itself doesn't leak, so it should be stored in a HSM and so on, so that the attacker can't just steal the private key material. Basic hygiene, really. So the attacker then wouldn't be able to generate the signature, so the resource server rejects them, and they can't actually use the stolen access token, which is good. And in FAPI 2, there are two choices for how you send a constrained access token. So there's Depop or there's mutual TLS. They both work very well. They both have their pros and cons. Depop is very much at the application layer. That means you can even do it in a web browser if you need to. Depop has a signature over the request URI, but not over the whole body. And it uses JWK key pair, so it's very familiar to anyone that's already working with JOTs. And importantly, it doesn't need any changes on the network layer, so you don't need to worry about what your TLS terminators are doing and pass stuff from the TLS terminator to the backend to validate. So if you compare that to mutual TLS, then this does have to be done at the network layer. It's just standard TLS client authentication, so it does require that you use X509 certificates, but importantly, it doesn't require that you actually have a whole PKI and everything. This works absolutely fine if you just use a self-signed certificate. This effectively fully protects the request because everything is being signed over, basically. And another advantage of mutual TLS is that, as we'll show later, it can also be used for client authentication, so you can kind of kill two birds with one stone. So many people prefer TLS, but yeah, the downside of the network layer and some people really not liking X509. Okay, so that's sender constrained access tokens. And some other things in FAPI 2. So it uses asymmetric client authentication instead of client secrets. So let's dig down into that a little bit. So again, there's two types of this supported in FAPI 2. You can do private key JOT or you can do mutual TLS. And the pros and cons are basically exactly the same as Depop versus MTLS. The private key JOT is at the application layer. It's just a signed JOT. If you're familiar with JOTs, it's good. You can do it in a web browser in theory, and you don't need to touch your network layer. Whereas mutual TLS, you need to touch the network layer, you need to deal with X509 certificates, but it does give you more protection because of that, because it is at the network layer. And you can also use it for the sender constraining of tokens. So again, you can kind of kill two birds with one stone in that sense, and it can be quite simple to implement. Other things FAPI 2 does is it makes sure you're using high security cryptographic algorithms. So PS256 as a JOT signing algorithm, or ES256 or EDDSA. You have to pick one of those. It has some explicit recommendations around how you use TLS, so making sure you're not using some of the insecure ciphers in TLS 1.2 in particular. And it requires the use of PXE, so even if your authorization codes are stolen, they're all good with because the attacker won't be able to use them because of the PXE. And we didn't just wing this. So as Daniel said, he started with creating an attacker model, and then the University of Stuttgart researchers actually took that attacker model and did a mathematical model of it. They did a mathematical model of the specification, and then they do the stuff that they talked about earlier to put those two things together and prove that the specification does actually meet the requirements of the attacker model. And they did throw up one or two things that we had missed, and they're all fixed and mitigated in the final version of FAPI 2. So this is something OpenID Foundation does in general now, is to do these formal protocol security analysis before we take specs to final to try and find things like this. Yeah, there is some complexity here, and it is easy to miss things. But these mathematical models are really good at picking up those things. And as Daniel said, FAPI 2 is also good for interoperability. It really does reduce the protocol options, so you have less to choose, which means there's less chance that the choices that you made are different to the choices other people make. So actual on-the-wire interoperability. And it uses pushed authentication requests, which again, it gets you interoperability and security and avoids things like needing to worry about, should I encrypt the request and should I sign it? Don't need to do all that, you just do PAR. And as Daniel mentioned, FAPI 2 also has conformance tests. So this is done by the team at OIDF that I lead when I'm not wearing my Authlete hat. And these tests have been adopted by multiple ecosystems around the world. So the open banking regulators in at least UK, Brazil, Saudi Arabia, UAE, all require that people run these conformance tests. It's actually mandated in the law in some cases. They have to pass before they can actually go live. And these tests are really quite comprehensive and good at picking up interoperability issues or security issues. And we get a lot of feedback from the ecosystems and people implementing and actually incorporate it into the tests so that the tests get better and better over time. So yeah, this is something that just can't exist at the OAuth level because you just don't have enough specified to actually, you just end up with a huge matrix of things that you have to pick. And then just because you've got a conformance test there doesn't mean that somebody else that has a conformance test with different options actually passes. And I shall now pass back to Daniel to talk about the current status.
Yes, thank you. Just to quickly wrap up, what is the current status with FAPI 2? Is it ready to use? Yes, it is. It is final. This is the first time I give this talk that FAPI 2 is final. It's final. Final specifications are never changed unless they are. So there might be error updates and stuff like that. But yeah, so the idea is FAPI 2 is final and stable. So you can use it. And you should not expect any changes, much less breaking changes. Yeah, and there's also the usual IPR protection that the OpenID Foundation specifications give you. And people are already using it. So there's various places around the world where FAPI 2 is used for some things, for example, FAPI 1 or 2. So FAPI 1, for example, is used in the Open Banking UK specifications, in Brazil, as Joseph already mentioned, USA for Financial Data Exchange, Saudi Arabia, and other places. FAPI 2 is being used, for example, in Japan, Australia, Norway, as I'm certain some of you know. In Germany as well, the yes.com ecosystem used to use it. We should update that. And
yeah,
yeah.
and this list keeps growing. I'm not actually sure if this one is up to date because I'm testing my geography now because I think we only recently heard that Rwanda has actually adopted FAPI, and I'm not sure if that blue thing is actually Rwanda or not. But I suspect it's not because I'm pretty sure we haven't updated the map. Yeah, we just hear about people you have already selected FAPI, and the first we hear about it is getting a question like months down the line from them actually selecting it.
Yeah, so if you know other places, please let us know. And yeah, to summarize, if you have an application where you need high security and interoperable OAuth 2, then FAPI 2 is what you want to use. It's the batteries included spec for high security ecosystems. The latest security recommendations on the wire interoperability, all the nice conformance testing stuff, couple of extensions that you might want to use, and as you've seen, a growing worldwide adoption. Thank you very much.